Welcome to you in my channel Mathematical Clinic of Subash. Today we are going to discuss some of the limit of the sum of the trigonometrical functions. The first question is evaluate limit x tends to pi upon 4 45 degrees sec square x minus 2 divided by 10x minus 1. This is the trigonometrical function, and if you substitute x equal to 45 degree, then sec 45 degree is root 2 whole square is 2 minus 2 0 divided by 10 45 is 1 minus 1 equal to 0. So this function takes the form 0 upon 0 when x equal to 45 degree. If trigonometrical function takes this type of form 0 upon 0, then we should do the numerical by two methods. First of all, first method one is whether we can cancel the factor 10x minus 1, because while substituting x equal to 45 degree here, 10 45 is 1 minus 1 is 0. If we will be able to cancel this factor, then we can get the answer. In this question we are going to do same. In another questions, we will apply the trigonometrical property to change sum and difference in the form of product. Somehow the form of product of either sine or tan, so that we can apply the formula sine theta by theta equal to 1 and tan theta by theta equal to 1 to get the answer. Here this is the first type of numerical I had discussed. We are going to use the technique here so that this can be factorized, and one of the factor becomes 10x minus 1. 10x minus 1 will be cancelled and we'll get the answer. That can be done by using this trick. Limit x tends to 45 degree as it is, this sec square x as it is, this 2 is written as minus 1 minus 1. Can you return 2 as minus 1 minus 1? Minus 1 minus 1 is minus 2, and denominator 10x minus 1 as it is. We have done this because we have the formula for sec square x minus 1. We have studied that sec square x minus 1 is 10 square x. We are going to use this formula here. So the result becomes limit x tends to 5 upon 4 as it is, sec square x minus 1 can be replaced by 10 square x minus 1 as it is, and denominator 10x minus 1 as it is. Can this one be written as 1 whole square? I have done so because we are going to apply the formula of a square minus b square here, algebraic formula. Limit x tends to 45 degree as it is, this a square minus b square can be written as a minus b into a plus b, and denominator 10x minus 1 as it is. Now 10x minus 1, 10x minus 1 cancel. The factor making 0 upon 0 has been cancelled. Now we simply substitute the value here. Put x equal to pi upon 4. 10 pi upon 4 is how much? 1. And this one is again 1. 1 plus 1 equal to 2. That's the answer. Once again I am going to tell you from the beginning. This question is sec square x minus 2 by 10x minus 1. If you substitute x equal to 45 degree here, then the function is taking the form 0 upon 0. So we will have to apply technique whether we can cancel 10x minus 1, or by the trigonometrical property this can be reduced in the form sine theta by theta or tan theta by theta. Here we have applied the first thing. We have written sec square x minus 2 as sec square x minus 1 minus 1, because we have the formula sec square x minus 1 equal to 10 square x, that is substituted here. Thereafter applied the formula a square minus b square equal to a minus b into a plus b. Factors have been cancelled. Substituted x equal to 45 degree here, 10 45 equal to 1. This one as it is, 1 plus 1 equal to 2 is the answer. Move to second question. Second question is find limit x tends to infinity sin x upon x. Actually, cause sin x lies between, no matter how large this x is, what the value of x is, because the domain of sin x is whole real number. The matter is where does its value lie. We know that the value of sin lies between minus 1, from minus 1 to 1. So because this one is the not fixed value, it has a range from -1 to +1, we have to apply a squeeze theorem here to get the limit of this function 1. I'm going to apply the squeeze theorem. To apply the squeeze theorem, we know that sin x lies between where -1 and 1. Suppose x is a positive number. In first case, let x be positive. So let us divide by x. It becomes -1 by x is less or equal to sin x divided by x is less or equal to 1 upon x. Because if you divide by the positive number, then inequality sign does not change. We are going to apply limit x tends to infinity. Therefore, limit x tends to infinity -1 upon x is less or equal to limit x tends to infinity sin x upon x is less or equal to limit x tends to infinity how much? 1 upon x. We know that if you substitute x equal to infinity here, it becomes -1 by infinity equal to how much? 0 is less or equal to limit x tends to infinity sin x by x is less or equal to, if you substitute x equal to infinity here, this one is 0 as well. So by squeeze theorem here, this number lies between 0, lower limit is 0 and even upper limit is 0. So by squeeze theorem, check the spelling theorem, the value of this limit x approaches to infinity sin x by x equal to how much? Either you can write the upper limit or lower limit, 0. If x is positive, then suppose this one is number 1. If x is negative, we did the theorem when x is positive. If x is negative, then let us divide it by x. It becomes -1 by x. If you divide by negative number, this sign reverses. Sin x divided by x, this sign reverses 1 upon x. Again apply limit x tends to 0. Limit x tends to infinity. X tends to infinity -1 by x is greater or equal to limit x tends to infinity sin x by x is greater or equal to limit x tends to infinity 1 by x. Again, if you substitute x equal to infinity, then what happens? This is 0 greater or equal to limit x tends to infinity sin x upon x as it is, and this one is also greater or equal to 0. Hence again, by squeeze theorem we can say that limit x tends to infinity sin x divided by x equal to how much? 0. So in either cases, limit x tends to infinity sin x by x equal to how much? 0. Move to third question 1. Third question is, find the value of the limit of this function 1. If you substitute x equal to 0 here, then cos 0 equal to how much? 1. 1 minus 1, 0. Denominator also 0. So this function also takes the form 0 upon 0 when x equal to 0. Here we cannot factorize, so simply use the formula of trigonometry, that 1 minus cosine theta can be written as 2 sine square theta upon 2. I am going to apply this formula to get the answer of this question 1. So this limit x tends to 0 as it is, 1 minus cos px can be written by this formula 1, 2 sine square px divided by 2. By the same formula, this can be written as 2 sine square qx divided by 2. 2 and 2 will be cancelled. Can this be written as limit x tends to 0, in the numerator sine px by 2, and here in the denominator sine qx by 2 whole square? Can you do so? You can, because the square of this becomes sine square px by 2 and the square of this becomes sine square qx upon 2. Now we are intending to apply the formula here, sine theta by theta equal to 1. So I am going to add here px divided by 2, sine theta by theta. So to balance it, you will have to multiply also by px divided by 2. Do same thing here, divide by qx upon 2 to apply the formula sine theta by theta equal to 1. To balance it, here also multiply qx divided by 2. 2 will be cancelled, x will be cancelled, and as you know, this one is 1 into p in the numerator, here 1 into q in the denominator. It's whole square, that is p square divided by q square. So simple. Move to next question. Let us find the value of limit x tends to 0 sine x degree upon x. If you substitute x equal to 0, this will also take the form 0 upon 0. We had established a formula, limit theta tends to 0 sine theta by theta equal to 1. But this formula can be applied only when this angle is in circular measure. But here it is in hexadecimal system, degree is given here. So first of all, let us change this x degree into radian. And you know better, to change degree into radian, you'll have to multiply by pi upon 180. Do so. This will be limit x approaches to 0 as it is, sine, this one becomes pi x upon 180 radian divided by x. Now to apply this formula 1, this angle must be same. Here angle is not same. We are going to make angle same in the next step 1. X tends to 0 as it is, sine pi x upon 180 as it is. Obviously it is in radian, not to be written now. Here x as it is. What are we lacking with? We are lacking with pi upon 180. That I am going to add here. To balance it, here also pi upon 180. This will be 1 into pi upon 180 becomes how much? Pi upon 180. That's the answer.